because you have the ability to watch the lesson. Are you recording it? Yeah. All right, so again, just as a real quick recap, we said this angle here was a 90-degree angle because we see the right angle symbol. We said these two expressions are not about degrees because there's no degree symbol. So even if we didn't know what the concept was in this particular problem, there's only one type of an equation we can set up. We would not add them together and have them equal 90 because they're about two different things. So the only equation we can set up is that equation right there. For those of you in class who wonder why I'm talking like this, that's for the people on the report. Now we're caught. All right, so if that's the equation, now all you got to do is do the algebra, solve that out, get what x equals. And then what do we do once we figure out what x equals? Make sure you answer the question, because the question is not what does x equal? Oh, actually, in this one, there's no question. So I guess you have to read the question. So if I said, what's the value of x, you'd be done. If I said, what is the measure, I guess you'd probably have to have some points here. Like if you had 2 points there, this was actually one of the book problems. That's why I'm doing it. If it said something like that, now they're asking you, what is the length of this line? The length of that line is not x. X is a part of that equation, but you'd have to solve for x and then plug it back in. Actually, here, I'll leave that there and we'll do that at the end. Really quickly, though, let me go over the concept. So here's the concept. It's this concept, but it's really not much different than this top concept. Bisectors are kind of the same thing, no matter what the original shape is that you're bisecting. Whether you're bisecting an angle, which is the case here. So we're bisecting this beginning angle. That's what we started with. We are then bisecting that angle with that line that's in the middle. How do I know that line is bisecting? Because I don't see anything in there that says it's there's no writing in there that says line. Nothing says line QP bisects the angle. How do I know that line is a bisector? What do you mean? How do you know that? That's what you mean. So these are the markings that tell me that middle line is a bisector. A bisector splits that outside angle that's highlighted. It splits it into two equal angles. That's what a bisector does. So when you do this lesson about bisectors, that bisector splits a line segment into two equal lines. So for example, that top IXL would be something like this. If I took that line and if I found the middle and if I bisected it with a 90-degree line, that's a bisector for a line segment. And the principles are the same. Any point on this line, this bisector, is going to be the same distance from this top side of the original angle as it is from the bottom. That's what these lines are showing, these blue lines. We measure distance at a 90-degree angle. So when we did the distance between a point and a line, don't remember, we had to flip the slope into a perpendicular slope, into a 90-degree slope. That's why we did that, because you measure distance at 90 degrees. So from this point to this line is 90 degrees. From this point to this line down here, this is 90 degrees. So we just want to know, or not know, that tells us that those two are the same length. The distance from any point on the bisector is going to be the same distance away from the edges. So if I put a point here, way down here, it would also be the same distance. Now it's obviously shorter than the blue lines, but those two lines would also be equal. Any point on that middle line is going to be the same distance from the two outside ones. It's the same thing over here. Any point on this bisector is the same distance from the two endpoints. So I could put that there. If I put one way up here, those two lines would be equal. So that's a super fast review version of bisectors. Again, I'm going fast because we've done it for a week now. Let's see what else before we finish solving. Get the 90-degree part. Means we're measuring distance. I think that's pretty much it. So that's your review. You're not doing practice. Well, you'll have like 10 or 15 minutes practice before the quiz. We have a new lesson though that you're going to be practicing on first. So let's solve it out. So I'll come back. Just remember that's the question. What is SP? So in order to solve, if I have variables on both sides, here's your algebra review. If I have variables on one side, I do need to combine them somehow. I can't just say that's 11x. You have to think about getting rid of the variables on one side. So that's how you get rid of that 4x. You subtract it. Mr. Gill's number one rule of solving, though, is whatever you do on one side, you have to do the exact same thing on the other side. So that goes away, which is it goes to 0 technically, which means it goes away. So the whole reason we did it was to get rid of that. So we wanted that to happen. I now have 3x subtract 5 equals 3. Now you should all hopefully remember how to do a two-step equation. Not, then you got to kind of practice that math on your own. So again, whatever, I'm trying to get rid of the 3 and the -5 or subtract 5. I do the opposite math, subtracting 5. The opposite is +5. Whatever I do on one side, I do on the other. And last step, again, I'm doing the opposite. 3x is 3 times x. Opposite of multiplication is division. Whatever I do on one side, I do on the other side. It is. You can leave it as a fraction, though. Well, I guess you kind of can. If you know how to use a calculator, you can. You don't know how to use a calculator, and you have to change that to a decimal to plug it back in. Because remember, the question was not, what is x? Do not forget to look at the question. I don't actually remember what I did on the quiz. If I said just solve for the variable, or if I said something more like this. I don't remember. So make sure you go back and look at the question after you solve for the variable. And now I say, okay, well, if I need to solve and find the length of SP, I need to take this value here, 8/3. So I need to say, okay, well, the length of SP is represented by this. Right? I don't know what that is yet, but I know that's the length. So I need to figure out what that is. Okay, well, I know what x is now. So 7 times, put a parentheses there. This means times if you don't understand what I'm doing. A number next to a number, if you have parentheses around one of them, means multiplication. So then subtract 5. So I'm going to do it long, old-fashioned way. So 56/3 subtract 5 equals 28 2/3 subtract 5. So what's that? 23. Something like that, I think maybe. Did anybody do it all the way out? Check on that. Not one single problem, person problem. Fair enough. I know I didn't have that up there originally. But I know what's on the quiz. Made it up, so I know what's on it. I gave you that for bell work. Probably a pretty good hint. What's on the quiz? Something. Any questions on that? Again, you probably get lucky and get the equation right. Then you just need to know how to do the algebra. Make sure you check the question for what I'm asking. All right, so here's the new part of the lesson. A little, you'll need your book pages. So take out pages 325 to 360. You are specifically, she erased my pages. I believe you're specifically turning to page 347. New, I know you have yours, Ronnie. Which page is that for you, right, Riley? Right? Go ahead, grab yours. Did you have a book that you were using? All right. Huh. 347. That it is the Circumcenter. You are correct. I don't think that I'm out of books. I've gotten a lot more kids. I gotta ask the Miss Pinster if she has any way to get more books. I guess you'll just have to do your best to take notes on it. Take notes on it today. Kira. Shoot. All right. I didn't even think about it. Of course, I also don't think we have any books anyway, so it doesn't even matter if I thought about it. All right, so we'll have to come back to that. I made popcorn twice, actually. I burned it the first time, so then I made it again. Yep. Popcorn is definitely a smell that well, part of that is because I dumped some of the burnt popcorn in the trash. That's probably part of the reason. For those of you that have not used this in other classes, I think we've used the online book since you guys have been in, is that right? Did you use it also in that? So we use the online resources. So IXL, which I hope you have used, but we also use the online book, which is, I've got a whole bunch of them, but this is the one that's the geometry one here. Oh yeah, it says geometry honors. So when you go into your Clever, you would go into the online book, which is called McGraw-Hill. It looks like a bright red M, or maybe actually like that. Then when you click on that, you go into that, and that's your online book. Oh. I think that's what's moving. No problem. So I've assigned stuff, so you can see in there when we go to practice, there's stuff assigned specifically for today's quiz. What I'm about to do is not on today's quiz, it's new material. It'll be on next week's quiz, so I'm just kind of introducing it today. 347 is this picture here. All right, so we actually did this before, but it's been a while and I want to go back over it, especially since we have some new people. What's that? Oh, maybe that's not what I thought it was. Oh, okay, that's not what I thought it was. There was something that they gave some kids because of a test they took or something like that. Yeah, maybe that was. Yeah. They also, I think I did see some other people get that one too, so I forgot about that one. I need to hide my tape is what you're telling me. Good to know. It's like this one because it's good for taking lint. So we said that there was a really good reason for this to find the circumcenter. That's what the only one we learned so far. Anybody have any idea? This is when I question my career choice. I have this question. Anybody remember why this is used in real life? Circumcenter. We're going to go back to it.
When there's a challenge in the big store.
Yeah, so we're going to use that exact example. So let's say we're going to start a restaurant. Oh, does anybody know anything about Tampa? Anything about Tampa? We'll start with that and then I'll narrow it down. Let's say first, because normally kids go no. So yeah, so it's here, right? It is one of the largest cities actually in Florida. Although I think they might include surrounding areas. It's bigger than Jackson. Nothing's bigger than Jackson. You know why? I live in Jackson. A bunch of cities. Well, the entire county is the same size as the city, or you can say the city is the same size as the county. Like here we have Pinellas County, but we have all kinds of cities in Pinellas County. They only have one city. Literally, their whole county is one city. I don't know why they did it like that, but they did. Yeah, I lived in Jacksonville for 2 years. It's crazy. So they're now people-wise, they're not as large as you might think. There's really not that many people, but land-wise, they're gigantic. They're still big. So let's say in Tampa, if you don't know these places, it doesn't matter. Has everybody ever heard of Hyde Park? All right. Have you ever heard of West Chase? Have you ever heard? Now we're into Pinellas. Have you ever heard of Feather Sound? Did I mention Feather Sound? Exactly. These are all very nice areas in this one area. This is South Tampa. It's a very upscale area. A lot of very nice shops, restaurants, that kind of stuff. West Chase, and this is more like, how would I explain it? This is kind of where you would go out. Like if you're
Kind of like E4.
if you're of the age to go out, that's where you would go out a lot of times. I would say it's a much nicer version of it. West Chase is sort of similar, very nice, but it's kind of a little more of a family area. Like, again, families that do very well for themselves. But very nice area. And then Feather Sound is in Pinellas, but again, very nice area. And it kind of has some of the single life and some of the family lives. But all of those areas have people that have money. So if you were to start a restaurant, it'd be really nice to put a restaurant somewhere where people from all three of these places can go. Because if I put my restaurant down there, you think I'm pulling a lot of people from West Chase? Probably not. Think I'm pulling a lot of people from Feather Sound? Probably not. Maybe a few, because it's a little closer than West Chase, but most likely I'm getting a bunch of Hyde Park people in that thing. So we would love to have a spot that is the same distance from all three of those so we can pull people from all three. That's what the Circumcenter is. It creates one point that will be the same distance from every single, it's called a vertex, the corner of a triangle is called a vertex. But we're just gonna, sometimes I'll just say the corner of the triangle, sometimes I'll say the pointy part. So all three of these, the point we create, which is already done for us, but it is the same distance from all three of those corners of that triangle. So all we did is connect each point. We just connected it with a side, by the way, to call that a triangle. So the way you create this is you take every side. So we're going to take this side of the triangle and we are going to draw in a perpendicular bisector. So we're going to split the line in half. So that's the middle. And we're going to draw a line in that is at a right angle. So that line right there. Oh, I missed it, but that's close enough. That line is one of the perpendicular bisectors. Then we do that for every side. That's the middle of the side. That line is the perpendicular bisector. That line is the perpendicular bisector for that side. When you do that, they will meet in one spot. That one single spot is called the circumcenter, and it is the same distance from every corner, but in our real life example, it's the same distance from every little hub, little circle. So we could say then that line, because again, I'm going from that to the corner, that to the corner, that to the corner. Those lines are all. So this is the kind. Oh, and one thing I didn't point this out in the others, but it's good that I'm recording this. What else can I say? There's other markings I could put in there, and you're going to do this when you practice in a minute. What other markings could I say are equal? Well, I don't know that well, which angles do you think?
The one A, G, and EG.
So this angle?
No.
This angle?
ADG and EG.
Oh, yes, we could. So we basically created an well, we did, but really the reason why it's not, I'm going to do two, I'm going to go in a different order because that's what you just said is correct. We split this. We know that's true. But what you said is true. Ronnie said, well, we know that angle is equal to that angle. Why do we know that? It's not because we split this segment. How can we say those two angles are the same? What kind of triangle is it? It's well, it's isosceles, right? So because remember when we did isosceles, which is also on your quiz, so it's not bad that we're mentioning this. Because we know these two sides are the same length in that triangle, automatically these two angles are the same. Don't forget about that, because there is a question on isosceles equilateral on the quiz. At least one, maybe two. So we could actually say that of all of them, these two would be the same as these two, because again, those sides are the same. We could say these two down here are the same as each other as well. But there's still some so what other markings could we put in about the sides? So this is correct here because we made a bisector, so we split that in two. God, waking you up. Has to do with what we did here. We can do that same or yeah. Yeah, on every side, right? We split every side in half. That's how we drew it. We split every side in half. So we could say that, and we could say that. These two are in the corner over the angle down there. So you can say a lot of stuff is the same in those triangles, in that particular drawing. And really, anytime you do this circumcenter thing, you'll be able to come up with something pretty similar. That will, so understanding what is congruent is what's going to be allow you to do the math, because I'm going to put some equations and numbers in the figure, and you're going to have to be able to figure out which equation matches up to which number, so you can set up an equation and then solve for the variables. Let's see, I think that's all we're going to do on that, because you're actually going to practice one of those later. So let's go. We're going to really quickly see if we can duplicate what we just did from an actual blank triangle. What is my first step to doing the circumcenter on that triangle on the left? Noah. How did we say we created? We don't see if there are any. What do? We're actually going to create some right angles. So how do we go about it? Like what is the important part? Remember, we have to do for that. We need to do a bisector. So for each side, we're going to do a perpendicular bisector. Now I don't know exactly where the I guess I could kind of do it. I think I did this in other classes. My little so if we measured, that's I had a longer. I guess I can use this one. Oh no, there it is. That's it. All right, so I can measure this. That's still not long. Oh, I thought I had used this, I guess. So let's see, that's from 1 almost to 14. I don't remember being 14, but so the bisector, let's put the cursor like right there. So we'll say that's about where it goes right there. I've already drawn a line that's pretty much perpendicular. So there's one of our, sorry. Got it. That's close. All right, so there's one. So I'm gonna do the same thing. So, here. Let's see, that would be from 1 about to almost to 20. So somewhere right about there. Hold on here, there. Oh no, got it. We're about there. And I think that's the line that's pretty close to perpendicular to that. And then this one is, I'm going to cheat a little bit on that because I know that line, since they always meet in one spot, that line has to go through that point right there. So that should be about the middle of that one. So there we go. Now, if you'll notice, that's not inside the triangle. Circumcenter does not have to be inside the triangle. It just has to be the same distance from every vertex, every corner, which those lines are pretty close to the same. Considering we just did it by hand real quick. all of those lines are the same. Now, again, if we went through that whole exercise, I could say these two are the same as each other. Those two are the same as each other. I split this side. I did 5, but I could still do 5. Skip 4. I already made that mistake. So that's really quickly example of what you'll see on the quiz next week. You've got to make or create all of those congruence marks yourself. Now, the tricky part's going to come when you're looking at the paper and I haven't told you whether it's this or this, and both figures look a lot alike, as you're about to see in a second. So now, well, when you get, if you're still doing the markings, now turn to page 355 when you're done. You're going to see that figure looks a lot like the one we just did. And you're going to have to figure out how they're different, because they are different. And I'll be honest, I have not come up with a great real world reason why we need this next one. I can come up with just a kind of a cool reason, but it's not really a real one. Is that the right page? Oh, no, one more. Wait, is that? Yeah, there it is. All right, so there you go. So as you can see, now we're on a different topic. Incenter, this word here, it looks a lot like what we just did. I got lines going to the corners. I got lines with right angles in it, but they are different. So when you see a quiz, and I have both of these shapes with all these lines drawing in, how are you going to know which is which? Is there anybody that's picked up on one thing that stands out just purely based on the pictures? There is one major thing. That's all you got to look for. So if the figure is drawn in a way that you can tell that, that's great. But what if I drew a figure that was pretty close to the same length and you couldn't tell that? There's something else that stands out that you can still look for, which I will. I wouldn't technically have to put this in there, but I will put it. Because if I drew this triangle more like basically an equilateral triangle, these would look pretty much like they were the same. Wouldn't necessarily know that visually. What else stands out? You need to go back and look at page 47. There's something that absolutely 100%. That's just because of the way the triangle is drawn, though, so you can't always rely on that. Again, if I drew something closer to an equilateral triangle, that wouldn't be the case. House. They did, so it's hard to tell if they're both in the middle. Something even easier than that. It's easier than everything you just said. What? The last one had 3 right. Now in the last one, we created the 3 right angles. That's not true in this one. We'll get to in a second. Something else. Look at the pictures. If you had the pictures side by side, which they actually will be pretty much side by side on quiz, so it may be easier. But first, you got to remember what to look for, which nobody said yet. Which bottom? So unlike the other one where we had isosceles triangles, we don't necessarily have isosceles triangles. But again, if I drew more of an equilateral triangle, that'd be tough to tell again. So I think this is why it's probably a little tougher. Think about what the shape looked like the first one we did, not this one, before we added anything to it. If you all added something to it, didn't add something to it, it's probably yours. Yeah, like you didn't add anything to that. What's different? You're looking at that bit, or is that? Oh, I'm sorry. Let me see 347. So whatever we just. Oh, you did all add it. So look at where your pencil marks are and ignore, say those weren't there in the original one on 347.
And you'll just say how to equal.
Which one's your what's it called? Say it again.
That on the website.
Well, that's kind of what we were saying, is that the sides aren't necessarily equal. But there's something in this original figure that was not in the original figure.
Oh, yellow line. The,
Not the yellow line.
no, the other lines, the.
Not the blue lines.
Okay, no.
Which red lines?
One's on A.
What is A? Angle, that's what I wanted to
So
say.
nothing, so.
So here's the deal. Now I'll give you the answer.
And
I did not have any markings in the angles. I had right angles in the middle of each side. I did not have anything in the, that's all you got. If there are no markings in the original picture, there's no markings, no tick marks, congruence marks, whatever you want to call them, in the angles of the figure, then it's the circumcenter. If you have markings in the angles, then it's this incenter. That's all you've got to do. I could make it more difficult and I could put markings in the angles of both, but I'm not going to. I'll just tell you that right now. So here's how this is created. And the reason there are markings in the angles. In order to create this, instead of bisecting each side like we did in the other one, we're going to bisect each angle. So we took each angle of the triangle and we drew a bisector through that angle. That's why technically it looks like this is just one mark and it looks like that's just two. It's really, I wish they would have done a better job of drawing it. It's really two small marks, one in each angle, showing that they're equal. This is really two small marks in each angle, showing that those are equal, showing that we bisected. Same thing here. This is really three small marks showing that we bisected that larger angle. So for every single angle, we drew an angle bisector. Again, when you bisect all the angles, those lines will also meet in one single individual point. That individual point is called the incenter. Again, I don't have a great real life example of why we need that, but I can tell you a pretty cool thing. If you ever want to like try this, if you had a triangular shape, it'd have to be a pretty perfect triangle, and it was a heavier material like wood or metal or something like that. Paper doesn't work great. Maybe I'll cut one of my whiteboards or something. If you did this and you found that, that's the balance. Like if you put your finger under that point, it will be perfectly balanced. That's the balance. I use that in real life. I don't know, other than balancing a piece of wood or something. So the rest of it, those right angles, what that means is if you find this, actually, I don't want to use it. If you find the incenter, that incenter is the same distance from every side. So if we took a line, if we measured the distance from that point out to every side, again, we measure distance perpendicular. That's why you have all the right angles. That point is the same distance from every side. Yeah, I don't think I was holding this first. I haven't gone over this in this class. I am taking phones again and keeping them because I've now lost 3 passes. So go ahead and go, you can trade me out. So again, we create this one by bisecting every angle. Once we find that point is the same distance from every side. It does not, I need something, utensil, whatever you need, or whatever you have, so I don't forget to get my pass done. So we did not, remember in this, we don't bisect the sides. So don't, that's my calculator. All right, go. Oh my God. So like, I'm just telling you what I'm going to do on the quiz. I'm going to draw something that looks like an equilateral triangle. So everything's going to look the same, basically. You're just going to have to understand these are not the same measure. I didn't bisect the side. I'm just measuring the distance from the point out to the side. So again, that's the kind of stuff you have to keep straight. I'm telling you what I'm going to put on there. You've got to figure it out when you practice. Some today, but mostly next week. So here's all you have to do, and then I'll give you have about 10 minutes probably to practice for today's quiz. So go to, there's a problem that's pretty difficult. You can do this problem all the way out. You're in really good shape. if you can at least get the markings in there, you're not in bad shape. Hold on, I gotta find this problem. Let's see. It might be back on the other one. One more page. All right, so here's your, you have it in your pages, so you don't have to look up here. If you don't have the pages, I'll leave it up and you can draw it. Page 347 at the bottom. That's your assignment. I want you to do that problem. It's not easy, not even close to easy, but here's what I would expect you to know. First of all, you need to figure out, is that, well, no, you don't, because it tells you the problem. So you know it's the circumcenter. I was gonna say you need to figure out which one it is, but they tell you. I won't tell you that on the quiz, so you may still want to look at it and make sure you can figure it out. They tell you that it's the circumcenter, so you need to go back and say, okay, well, how did we create that? Okay. Once you know how we created it, I want you to put congruence marks into that figure. Kind of like what we just did on the other. If you, a lot of you guys saw what we put after the, yeah. So put the congruence marks in. Once you've done that, there's one number. I'll just tell you. Well, actually, I don't even need to tell you because they tell you here. Yeah. They tell you where that 4.25 is being used. They also tell you this. I think this one's a little more obvious. I think it's pretty obvious what that is representing. And then they want you to solve for this little guy right there. That's what you're solving for. Now, if you can go all the way through and do that, that's fantastic at this point, because we're going to do this a little bit next week. But at the very least, today, you should be able to put in the correct congruence marks. What pieces of that are congruent to each other? We already did it once on the problem right above it. Third. Too slow. Third. I'll find out later. Every day for the last 3 months.
I've been here.
I know you're here early and then you leave. Don't come back. Hmm. We'll do this. So the quiz took about, really only took about 20 minutes, but I'll give you more time than that. To start the quiz. 5. So we'll do this. I'll give you like almost 10 minutes to work on that one. So when we get to about the 3, then I'll give you 10 minutes just to maybe look some stuff over and refresh your memory. No, you won't really have time to do Excel or any of that. If you can at least look at the book pages. And then we'll start the quiz like somewhere between 5 and 6. That'll give you between 25 and 30 minutes. Based on the class difference. Oh, did I tell you what happened? Kidnapping? I didn't tell you about the kidnapping. I did tell you, you guys remember. My class. Kidnapping. Kidnapping.
Oh, yeah, it's a joke.
Yeah, I woke him up and flying after that. You love that joke. I even told you guys how you didn't remember it. Wow, Henry would remember it.
I remember it.
Did you? Not initially, you didn't. You just, oh, yeah, then you're. I haven't told that in my other classes. I keep forgetting. Probably because I have more people sleeping. One. Zero.
Yeah,
One.
okay.
Actually, now. Looks like it. 1, 2, 3. Oh. Everybody's waking up. They want to hear my joke. Or no, they heard about a kidnapping. You know, I mean, there is always kidnapping. That's fine. You guys need to get that relief. How you gonna survive, get jobs where you have to actually function.
That's why I don't. Better reason I have a job.
So are you awake at your job? I was gonna say, how late do you work?
Depending on the day, I can work up till like 9:30, 10 o'clock, and then I wake up at 5:30.
Well, that's when my alarm goes off, not gonna lie.
Mine too, sometimes I'll wait until 6 to get up,
That's why I,
but then
well, I.
because my sister comes in and literally like, she's like, get up, I'm like. "Oh."
Good. Good. Um. This is how you have to do it. This would be, oh, no. Well, because you know, this, like here, this one is 4.25. That's actually that's the long side. So you had C is what you're solving for. You're actually solving for A or B. This C would be 4.25. But that's good that you, again, like I said, if you getting that far is fantastic. I was looking for, checking for your phone. Oh, I lost this one. Here's the- oh, you do have a phone, sorry, so grab that. As long as they're the same, you know, one. Do you know what the strategy would be to continue moving forward? When you see a right triangle, what's the first thing you should think about? This is kind of for everybody at this point. If you see a right triangle with a formula, you should, actually, the first thing you should think, how to use that. A. Oh.
Vacuum.
Not exact, so what is it?
An A squared plus B
A
squared.
squared plus B squared is C squared. So the longest side is C. You actually know what that is, so that would go on the other side, you can sign all that stuff. And then the A or the B doesn't really matter if you find that. Okay? So the missing side would be either your A or your B, so that'd still be a variable. That side. How do you find, so your triangle you're solving for is the right triangle exists. How do you cut that? You know this. That. You don't know this, so we're solving for that. How do we get this? So then you know 2 out of the 3 sides, you go square B squared C squared, you're solving for either A or B. Like, do you not have it at all, or you don't have it today? It's always to have it, we'll get to it. Yes, fantastic. And then you solve, so yeah. Solve for, and remember at the end, you're gonna have to take the square root, because you're solving, technically what you have is B squared, so you have to take the square root to find. On the, I don't know which calculators you use, but these are a little weird. You actually, most of the time you put the number in first in the square root. On these, you actually. Yeah, above that, above the square root. So you'd actually hit second and then that, then put the opposite of them. Well, I mean, that's what a lot of kids did is that, oh, well, this is it kind of looks like an isosceles. That's pretty probably is. But you can't assume that, so we can not assume. There are all kinds of triangles. So this 7.79 can only be used down here. How do we create this circumcenter? What did we do this? Didn't do anything with the angles to create. How did we create it? What do we do to get that point?
Oh, we mentioned it.
Yeah, so so it's a perpendicular line, which means this is the midpoint, which means what? This, B.
That means, uh,
Well, not B wouldn't be happening, what? Be very specific. B is just 1 point, it can't be happening. What would be happening? Something is happening, it's not just B. It's not BS, get a little closer. What is 7.79? Tell me. 9. So if Q to V to R, so really Q to R is 7.79. This is the midpoint of the line. So what's that term? V is the midpoint of
it is
these.
the.
Well, it is, that's how, I'm talking about congruence, think congruence. That's if B is the midpoint of QR, what would you know? I see QB. There you go, that's what, yeah, so this. Hanging on by a thread. So this segment equals that segment because we bisect. Should now be able to go through it with some more. Yeah.
Yeah.
I don't. Oh, did you have a question?
Yeah.
Oh, I was gonna say.
I got it up.
That's fine, I'm not concerned about that.
Sure.
So second function, and then just remember, they're kind of opposite things, it's kind of better. Squaring and square roots, but it just defines the top function. Did I hit second? Yeah, so now, so see how it puts that in there, but it doesn't do a calculation until you put the number. And a lot of times you have to hit equals. Are you asking a question or are you asking? You're after J, wait, you're still waiting. Right? So you're after him. Oh, who's spoken? Question about math or question about math? Oh, right. It's ish. Ish. When you're doing the right concept, the longest side is the side across from the right angle. So this is actually the longest side. So the side that we know is actually C. Is because we're solving, so I'm just gonna kind of highlight it out. So this is the right triangle. We know this, so that's the C, so it goes over here. A and B doesn't really matter which one we make the variable, we could make this the variable. Well, no, I'm sorry. This is the variable, so we don't know it, but we could say that's A or B, that doesn't matter. I think this may just be the other one. I don't, yeah, okay, so we do that. If you just switch those two. Just be careful when you look at the triangles, how you. So you kind of same thing for you, well, two things actually for you. This number right here, which we know is the same as this, right? Go one in there, one there. One in there. Well, tell me what you're marking. Points, it's very there, it's that and that. Those are good. Those are good. So there's only one thing you missed, so now These are the same, but this point is the same distance from every point. So this is the same as this, which is also the same. This, right? Which means this is 4.25. And this is 4.25, right? Did you already look, you understand that? Or? So if this is 4.25 here. That's when you're doing A squared, B squared, C squared, C is always the longest side, or you could say C is across from the right angle. So this side is the C. Yeah. Okay. I know this is a tricky, it's not that you can get the mark in front. So the only other thing that you need to remember is you have this correct, these are equal, right? They're not both 7.7. I don't know if you're trying to use this whole length when you're trying to do this. Okay, so we don't just use the numbers because they gave us all the numbers. We have to use this piece right here, because this is the right line. So I'm using this side, and I'm solving for this side. So what would I need to do? And then, so you switch these two, but before you switch them, you go back. Good. So you're in good shape. Then. Did you finish that one, Ronnie, or are you still working on it? What did you get?
Well, I found it back in 2020,
Oh,
3.20.
or was that for the final answer, or was
Yeah.
that for? I'm getting a different, I think you're looking for, well, let me just look at those two. So we would say that's it's good. Please wait to. I'm gonna assume you. Change the map. So, go try to correct, because it looks like, yeah, I'm not. Look like you move it over, all of a sudden you went from subtracting to adding. It's just so this, where did this come from?
I know. Yes.
This, where is this? It's this, this. This. Let's try. You gotta. That's it, because you went from this, how did you go from this number to that?
Because I had this number's right here.
Yeah,
That's fine. I had like,
divided by two, get to you did.
yes. And then,
How did you go then?
um,
They can know what you did.
yeah, I know that it's really.
That's what I thought. So yeah, so you did everything correctly, except you did square this down here. It looks like that does look like it's 4.25 squared, but you multiplied that. So yeah, because your equation is correct. That means. Perfect. Now solve. Was there another hand up? You were just waiting. Yes. Did you find the paperwork yet or start? You need new paperwork? There we go. You did it. That's fine. We're gonna start with conditioning for the first hour or so, and then we got things. Well, yeah. Actually, I guess that's how it's right. For the first probably 45. And then we're gonna play a game, which is actually sort of football skills related. But we're not bringing football, we're gonna do it with something else. Kind of like capture the flag, sort of. Well, we're not in season yet. Like the season doesn't start until 6, so we're not allowed to do it. Those two. Those are working. Yes, that's what I want you to do. Exactly what I want you to do. So we'll like it. Fine. Well. Sometimes kids just, yeah, not understand. But you hear me talking to other kids. Explain to me why you might. And what we need. So what we're ultimately gonna do, you kind of have some. You're ultimately gonna need to solve this. That's. Where we're gonna solve it. We need to have the range. That's like. You know what this is, same as that, so we have one number there. Well, if I do what you just said I should do, I have a number there. So if I have 2 out of the 3 sides, the right triangle, I can solve for the third side, that's the. The only tricky part is, you need to be very careful when you plug in the values for A, B, and C. So far, everybody's gotten that part wrong. You gotta figure out which sides do you know and which sides you solve. Little tricky. Did you redo that? What did you get this time? Good. So you said this, subtract that, right? Hey, I was just gonna say, perfect, then you're done. That's you take, now, the thing about those calculators is on other calculators, you could just hit square root right there and it would do it. You have to actually remember that number, go backwards, hit the square root button, then put the number in it. So I actually don't like these calculators, but supposedly they're specific for geometry, so that's why they get. Absolutely study. Oh, yeah, crap. We gotta do this. So look, if you wanna look at notes, real quick, totally forgot. Look at notes for a couple of minutes. If you wanted to, you could probably get away with going until the 6. I was planning to start it in like 2 minutes. Want to take 7 minutes? Still most likely have plenty of time. Time is not an issue. The last class actually only had 20 minutes. Time wasn't an issue. Well, one person stayed a little bit longer to do it. So again, but I'm definitely gonna give it to you by the 6th. If you think you're good, then I'll give it to you whenever you're ready to start it. We'll put all your, look, you gotta put all your stuff away first. Any note, I don't care if this stuff is out, but you can't have any notes out on, that stuff. Get the food done thing. Just better to just put it on. Just 5. And 2 of them don't really have any math, so there's really only 3 that have math in it. They don't have any calculation. It's conceptual math. Andy ready? No, you hit the second function and then the x squared, which will give you the square root. And then you put them. Done. No.
Alright.
Also, use it all has to everybody roll. Oh, is somebody out there? No, who's out? Oh, yeah, her. Go ahead, go just say it. Oh, I'm sorry, yeah. So go real quick, Aileen. Again, 25 minutes should be plenty of time. If you get, so what would the square root of that be?
X square root.
1.5.
Oh, X square root. Oh, that's X square root. I got that.
Yeah.
1.6.
Yeah, fine. Year after whole one. So go. You ready? All right. That page, that's all. Throw on me. I'm going to get what's on. Oh, well. Awesome. Yeah, sure are. Good, you can retake it. It's better to know what's on it than retake it than not.
The 20th, I believe.
Study it, you can't do any of it. Just study
Yes,
what's on it.
20th.
Study what's on there. Taking the retake on it, I'm sure. What lunch do you have? Hi. What lunch do you have? Yeah, first lunch? Where have you been? You don't get to go anymore. Or more. Jaylene already went. I'll leave it up to you if you want to work on that for a little while, or if you want to go now. Somebody, Trevor, back. I don't know what. Do it after. Somebody was after the poll. It's after the poll. Well, no, somebody already said after. Was it you? Yeah. So after you're after. Assuming we still have time. That'd be good. Time wise, you're actually you got still plenty. Anybody not? Oh, Hmm. Hmm. I can figure that out. I did not give you a quiz. Quiz number two. Oh, there. I guess I'll set a timer. That makes sense. Leo's here.